Hello everyone, I am Navneet Sinha from NIT Delhi. Currently, I am pursuing MTech in CSE branch. Here, I am going to give the presentation on computer vision. So let's get started. Coming to the contents of my presentation, first, definition of computer vision. Then I'll compare human vision versus computer vision, edge detection, types of edges, process of edge detection methods, overview of gradient and hysteresis threshold, Roberts operator, Rivet operator, Sobel operator, Canny edge detector, Laplacian of Gaussian, bag of words, human action recognition model, and finally, we will discuss applications of computer vision. Coming to the definition of computer vision, it is a scientific field that deals with how computers can be made to gain understanding from digital images or videos, and the representation of these images as sets of numbers or symbols for computer processing. So it is a field that includes processing, analyzing, and understanding of image in general. So high dimensional data from the real world in order to produce numerical and symbolical information. Here we can see the comparison between human vision and computer vision. So there is an image as an input. In human vision, the processing is done by the brain and the eye, which gives the output. In computer, the processing is done by the computer or some sensing devices like cameras to recognize this image and give the required output. So the basic functionalities of computer vision is to recognize an image. So for this image, it is a cat or not. So coming to human vision versus computer vision. Here we can see images like black and white images. Computer can use binary numbers like 0 and 1, where for this particular image, 0 represents white pixels and 1 represent black pixels. Similarly, for gray images, there can be more than two representations as compared to black and white images. We can see here for this image, 256 levels of intensity are there to describe this image. For color images, we have different specifications. Now coming to edge detection. So what is an edge? So edge refers to a boundary between two regions in an image that have different properties such as intensity, texture, color, or depth. Edge are important features in image analysis. So what is the usage of edge detection? So actually, detecting edges in an image is a fundamental task in many computer vision applications. We can determine or recognize the boundaries, objects, and segmentation. So the types of edges are step edge, ramp edge, ridge edge, and roof edge. We can see the diagram over here. Process of edge detection. So there are three steps to perform edge detection. First one is pre-processing. Here we prepare the image for edge detection by applying various operations such as noise reduction, smoothing, and contrast enhancement. The second step is edge enhancement or edge detection. It involves detecting the edges using various mathematical operators like Privet, Sobel, or Canny operator, which we'll going to discuss in the further slides. Then comes the detection or identifying the edges, that is post-processing. It involves post-processing the detected edges to improve their quality and remove any noise or spurious edges. Various techniques used are thresholding, edge linking, and edge thinning. So edge detection methods. So there are two types of edge detection methods, gradient based and the Gaussian based. In gradient based, we are going to discuss Robert operator, Privet operator, and Sobel operator. Inside Gaussian based, we're going to discuss Canny edge detector, Laplacian of Gaussian. So before going to this operator, first we will give the overview of gradient and hysteresis threshold. So the gradient of an image refers to the rate of change of the image intensity at each pixel location. Hysteresis thresholding is used in image processing to extract edges from the image. It basically shows or describe the high intensity edge and the low intensity edge. So this is just the overview before going to the operator. So the first operator which we will going to discuss is the Roberts operator. It consists of 2 cross 2 matrix of coefficients. It is also called a mask or a filter, which is applied on an image. This operator works by comparing the brightness of adjacent pixels in an image to detect changes in intensity. There are various problems included with this Roberts operator, such as like the number of neighboring pixels considered in one go is very less, and calculating 2 cross 2 matrix is very tough. Hence, we have stopped using Roberts operator in image classification or in computer vision. Now coming to Privet operator, it is a 3 cross 3 matrix convolved with an image to detect edge. Here in the image, we can see there is an original image. We can determine the vertical edges and horizontal edges over here. So as compared to Roberts operator, Privet operator is very much more complex filter and can produce better results and in noisy and complex images. So here we can see the original image, which has some random pixel values of colors. We can use the filter to detect vertical edge and filter to detect horizontal edge. For vertical edge, we are using -1, 0, and +1 in the column-wise manner. Horizontal edge, we are using row-wise +1, 0, then -1. I will show you the example of Privet operator. So here we can see the example. There is an original image 6 cross 6. We have to determine this edge. There is an edge over here. So this is edge which we will going to determine using Privet operator. So we are using a 1, 0, -1 filter, which is the column-wise filter or mask. So we are going to put this filter into the image. Okay. So if we put this filter inside this image and calculate the value, we will get 0. How? We can calculate like 10 cross 10 plus 10 cross 0 plus 10 cross -1. And again, for the second row, 10 cross 1 plus 10 cross 0 plus 10 cross -1. So basically, we are doing multiplication and adding them all. So if we do the multiplication and add them all, we get the value as 0 over here in the first row, first column area. Similarly, for finding the second column and first row, we will shift this, apply this filter over this area. So it will be like 10 cross 1 plus 10 cross 0 plus 0 cross -1. Similarly, 10 cross -1, 10 cross -0, 0 cross -1. So this is how we will going to calculate the value of the second column and first row. That it comes out to be 30. We can check that. Similarly, for the third column, first row, the same technique we will use. For the fourth column and first row, we will use the same techniques. Here we can see all values are zeros. If we multiply and add it with this, we will get the value 0 only. Now for first column and second row, we will take this image part. So here is the edge which we have to determine. Okay. So after calculating it, we will get a value like 0, 30, 30, 0, 0, 30, 30, and again 0. So we are determining this area where the edge is present. So here we have detected the edge using pivot operator. Now coming to Sobel operator. It is similar to pivot operator, but you will see the matrix, different matrix that places more weight on the center pixel. You can see over here for the vertical edge detection, we can see the middle pixels have more value like -2 and +2. For horizontal edge, the middle value are +2 and -2. It is similar to the pivot operator. Coming to Canny edge detector, it is a multi-stage algorithm. Here we apply a Gaussian filter to the image to smooth out the noise and reduce false edge. Then we calculate the gradient of the image using Sobel operator. Perform non-maximum suppression, which involves thinning the edge to produce a single pixel wide line for each edge. Then we apply hysteresis thresholding, which involves setting two threshold values to determine which edge to keep and which to discard. This technique will give us the uh, high intensity edge and low intensity edge. So we can filter it out. Finally, connect the remaining edge pixels into continuous curves. It produces high quality edge detection results that are accurate and reliable as compared to previous edge detector operators. Finally, Laplacian of Gaussian. It combines two filters, the Gaussian filter and the Laplacian filter. This operator is applied to an image by first convolving the image with the Gaussian kernel to smooth out the noise. The Laplacian operator is applied to the smoother image to obtain the second derivative of the image. The resulting image is then thresholded to obtain the edges. The edge detection results of the Laplacian of Gaussian operator are more accurate than the other edge detection methods. However, it is computationally expensive and requires a significant amount of processing power. Here, the second derivative, which I'm using, is a measure of the rate of change of the image gradient with respect to position or space. Here I can give you the examples of various operators used, edge detection operator used. This is the original image. This is the same version used by Canny edge detector. This is Laplacian of Gaussian. This is the Privet. This is the Sobel, and this is the Roberts operator. We can clearly differentiate the edge over here. Now coming to bag of words. It is a common feature extracting technique used in computer vision and natural language processing. So basically, it breaks up the text or an image into smaller units such as words or image patches. So here I've given an example of an image. However, we can do this for the words as well. Then we use feature vectors to create a vocabulary or dictionary of visual images or textual words. Each image is then represented as a histogram. I will show this in the next slide. Here, we are extracting features from every image. Like from human, we have extracted images. From bicycle, we have extracted these images. From guitar, we have extracted these images. Now we will create the visual vocabulary. Then we will create the histogram for every figures. For human, we have created the histogram. It will extract the features of the human and it will show the histogram of that. Here we can see these and this part is of human and it is showing the highest feature vector for this. Similarly, for bicycle, it has the highest feature vector. For guitar, this is the highest feature vector. So the resulting histogram can be used as a feature vector to represent the document or image in a machine learning model. Now coming to human action recognition. So here our goal is to automatically recognize and classify the actions performed by the humans in videos or image sequences. So there are various applications for human action recognition. Here I've shown the HAR example for cricket. Here the umpire is giving various instructions using his hand gestures. There are other various applications in security, surveillance, healthcare, and entertainment. So there are various levels of human actions. You can see humans uh, can be like walking, sitting, or bending, running, etc. If it's interaction, then it can be like human to human interaction or human to object interaction. Example, punching bag, lifting a bag, etc. Group activities like group dancing or group fighting. These are the group activities. We can see how humans are interacting with each other. Now, approach to human activity recognition. The main goal is to identify what is the activity of the human. So here we can divide the human image into rectangular segments to track them in frames. So here we can see uh, divide the human body into rectangular frames. From this rectangular frame, we can identify what is the current action of that human. So how we will going to divide this or identify this particular rectangle? We are using the searching technique here. Searching means we are finding that region where the pixel by pixel match is very high. This is the second approach of human activity recognition. Here we are going to subtract the background and extract the desired object of interest or desired human body structure. Like here, this is the background. Here we can see a human body is kept. We will subtract this from this particular background image. We will get the desired result. Finally, coming to applications of computer vision. There are various applications from defect detection to intruder detection, mass detection to tumor detection, crop monitoring to plant monitoring, vehicle classification and analysis to traffic flow, customer trafficking, and theft detection. These are the references which I've used. This is the Artificial Intelligence book, A Modern Approach, 4th edition, written by Stuart Russell and Peter Norvig. Thank you.